In this lesson, we are going to talk about the movement of a couple in two dimensions. When we have two equal and opposite forces separated by a certain perpendicular distance, like the pair of 200 Newton forces that you see here, separated by a distance of 0.4 meters, then these two forces are said to form a couple, and the moment generated by such a couple is called a couple moment. For example, for this pair of 200 Newton forces, in this case, the couple moment MC generated by this pair of 200 Newton forces is equal to the magnitude of one of the forces multiplied by the perpendicular distance between them, giving us 80 Newton meter. In this question, however, we are asked to determine the resultant couple moment acting on the triangular plate. The pair of 200 Newton forces is just one of the three couples that you see here. The other pair being the 150 Newton forces and the 300 Newton forces. So altogether, we have three couple moments generated by these three couples here. And the question wants us to calculate the resultant couple moment. The first step is to first identify a certain positive direction. In this case, if we choose positive as anti-clockwise, then that's how we write it down. Resultant couple moment is equal to summation of all couple moments. Alright, first we look at the couple 1 here in green. As I've written earlier, the couple moment is just 200 multiplied by the perpendicular distance, which is 0.4 meters, followed by couple 2, which is 150 newtons, multiplied by 0.4 meters. Again, in both these cases, the couple moment generated goes in an anti-clockwise direction, so both are positive couple moments. And then for couple 3, we have 300 multiplied by also 0.4. In this case, it is also a positive couple moment because it turns in an anti-clockwise direction. So we have 0.4, we take out the common factor, so we have 200 plus 150 plus 300, which gives us 0.4 times 650, which gives us the final resultant couple moment of 260 Newton meter. Let's move on to the next question. Determine the couple moment acting on the beam. So in this case, we have two forces acting on the beam, and they are equal and opposite, and they are not collinear, meaning that there's a certain perpendicular distance separating these two equal and opposite forces. So they form a couple. And because they form a couple, there is an associated couple moment that the question wants us to find out. In this case, it is not easy to find out the exact perpendicular distance between the two forces. So the strategy for such a problem is to resolve the forces into both the vertical and horizontal components. Shown here is the 10 kN force acting at the top. It has been resolved into its vertical and horizontal components. The magnitude of the horizontal component is just 10 kN multiplied by 3 over 5. The magnitude of the vertical component is 10 multiplied by 4 over 5. Shown here is the 10 kN force at the bottom resolved into both the horizontal and vertical green component. The magnitude of the horizontal orange color component is 10 multiplied by 3 over 5, and the magnitude of the vertical green component is 10 multiplied by 4 over 5. So now you can see that instead of just having the original couple of 10 kN forces, we have two new couples, both the horizontal components and the vertical components. So in other words, the vertical components form one couple and the horizontal components form another couple. So once again, we take positive as anti-clockwise, and we have resultant couple moment is equal to the summation of all couple moments. In this case, first we look at the horizontal forces, these two forces that form a couple. We have the magnitude of the force times 3/5 multiplied by the perpendicular distance between the two, which if you were to look at the figure, the perpendicular distance between the horizontal components is simply 1 meter plus 1 meter. So it's multiplied by 2. And not forgetting that this couple moment is actually positive because it rotates in an anti-clockwise direction. Now the next couple moment is due to the vertical components, which tends to rotate in the clockwise direction. Right? One is going down, the other one is going up. So we have to put a negative sign here due to our convention that positive is anti-clockwise. The magnitude is simply 10 times 4/5 multiplied by the perpendicular distance between the two, which is just 4 meters. So we end up with 12 minus 32, which gives us minus 20 Newton meter. This tells us that the resultant couple moment is actually acting in the clockwise direction because of the negative sign here. So you can also say that it is equal to 20 Newton meter clockwise. Our next question is slightly more complicated. Determine the required magnitude of force F, which is this force here, if the resultant couple moment on the frame is 200 Newton meter clockwise. Looking at this diagram, we know that this force F here and this force minus F here form a couple. And this force here, 1500 Newton, and this force here, which is equal and opposite in direction, form another couple. So using the same strategy as in the previous question, we look at this force now here, and we resolve this force into its vertical and horizontal components. So this is the vertical component in orange, and the magnitude of this force is 4/5F. This is the horizontal component pointing to the left, and the magnitude of this horizontal component is 3/5F. Here is the 1500 Newton force acting at this point here. It is depressed at an angle of 30 degrees to the horizontal. The vertical component is shown here in red, and the magnitude of this vertical component is 1500 sine 30 degrees. There is also a horizontal component shown in this blue color vector here, and the magnitude of this horizontal component is 1500 cosine 30 degrees. In this case, we choose positive to be clockwise because the question says that the resultant couple moment is 200 Newton meter clockwise. So resultant couple moment is equal to a summation of all couple moments. In this case, for the first one, let's choose this vertical component of the force F. This vertical component, which is located here, will form a couple together with this vertical component pointing downwards, and it is obviously an anti-clockwise couple moment. So we have minus 4/5F multiplied by the perpendicular distance, which is 0.2 meters, 0.2. And now let's take a look at this green component, horizontal component, which is located here. And this force here will form a couple together with this force here. And it tends to rotate in the anti-clockwise direction, so it is once again a negative couple moment, the distance between them is actually 0.2 meters. So it's minus 3 over 5F multiplied by 0.2. Next, we look at this red color vertical component of the force of 1,500 newtons. The location of this vertical component is actually here. And this will form a couple together with this vertical component here due to the other 1,500 Newton force. The perpendicular distance between these two vertical components is actually 0.2 plus 0.2, which is 0.4, and it rotates in the clockwise direction, so it is positive according to our convention. So we have plus 1,500 sine 30 degrees times 0.4. Finally, let's look at this horizontal blue component here, which is acting at this point horizontally, and this force here will form a couple together with this horizontal component here, also in blue, and it rotates in the clockwise direction again. At the same time, the perpendicular distance between these two blue horizontal forces is actually 0.4 meters. So we have plus 1,500 cosine 30 degrees times 0.4. And we end up with 819.62 minus 7 over 25F. According to the question, this has to be equal to 200 Newton meter. So this implies that 819.62 minus 7 over 25F is equal to 200. And if you were to solve for your F, that will give you 2212.93 newtons, which is around 2.21 kilonewtons. To three significant figures. So in this lesson, we have talked about the movement of a couple in 2 dimensions. The strategy is always to resolve the forces into both the horizontal and vertical components if you do not know the perpendicular distance between the two couple forces. Hope you enjoyed the lesson. I will see you next lesson. Thank you.